Hello, so the next section of this booklet is the cardiac cycle. Now, what's really important before you go on and look at this is that you've got a really good understanding of the different structures of the heart. So what I think you should do here is pause the video and make sure that you can label each of these parts and that you understand how each part is connected together. And that you also understand which direction blood flows through the heart. So pause it here, see if you can label these parts. And then here's the answers. Now, again, as I said, it's really important to understand how blood flows through the heart, especially when looking at the cardiac cycle. So what I want you to do is draw a little flow chart to show what structures blood flows through or flows past on its way through the right-hand side or the left-hand side of the heart. So, for example, if we start at the right-hand side, what structures does it flow through? It comes back to the heart in the vena cava. Where does it go next? What valves does it pass? What chambers does it go through? And then what artery does it go out of? Okay, so think about the chambers, the valves, and the arteries that it goes out. So pause it here and see if you can do it for both sides. So the right hand side, the blood will come back in the vena cava, go into the right atrium. It will pass through the tricuspid valve, and then it will go to the right ventricle. It'll pass through the semilunar valve and then into the pulmonary artery. And from there, it'll go to the lungs. On the left-hand side, now this one's really important because most of the cardiac cycle is based around the left-hand side of the heart, especially the diagrams and questions and things. So the pulmonary vein brings blood back to the heart. It goes to the left atrium, through the bicuspid valve, into the left ventricle, and then up and out the aortic valve or the semilunar valve into the aorta. And that's how blood flows through the heart. Now, what we're going to be looking at here in the cardiac cycle is all the different pressure changes which take place in the different areas. So it's really important that you understand if blood is in the left atrium, that when the atria contract, the blood is going to flow into the left ventricle. And when the ventricles contract, the blood is going to be forced through the aortic valve into the aorta. Now, it's really important to understand where blood flows because it'll help us explain the different stages of the cardiac cycle and also the different pressure changes. Now, this is a good little video just to show an introduction into the cardiac cycle. You'll be able to find this in the file section. So I would maybe pause this here and watch the other one. And then once you finish that, we're going to have a look at this, which is a cardiac cycle. Now, in the cardiac cycle, there is 3 distinct stages. We've got diastole, atrial systole, and ventricular systole. Now, some people will just call this diastole, and then atrial systole and ventricular systole. But it doesn't really matter what you say. Now, the 3 stages here is diastole, which is where the whole heart is relaxed and it's filling with blood. We've got atrial systole, which is where the atria contract. And then we've got ventricular systole, where the ventricles contract. And just to look at that in a bit more detail, diastole is when all the chambers are relaxed as the heart fills with blood. So the atria and the ventricles are both relaxed and they're filling with blood. Then the atria start to contract, and that's known as atrial systole. So the atria contract, force blood through the AV valves and into the ventricles. And when complete, the AV valves shut. Now remember, these valves here, between the atria and the ventricles, those are the AV valves. So here we've got atria, here we've got the ventricles, and there we've got the AV valves. Then after that, we've got ventricular systole, which is where the ventricles contract, which forces blood upwards and outwards into the arteries. And then when it's finished, the semilunar valve shut. And that will continually repeat. So each cardiac cycle is made up of 3 distinct stages: diastole, atrial systole, and then ventricular systole. Right, so let's look at that with an actual heart diagram which is moving. So, as I say, there's 3 stages in the cardiac cycle. There's diastole, which is where the whole heart's relaxed. There's atrial systole, where the atria contract, and then ventricular systole, where the ventricles contract. So if we start this right at the beginning, this is during diastole. Now during diastole, the heart is filling with blood and all the chambers are relaxed. So blood will passively enter the atria, and then when it gets to a certain point, the AV valves will open and the blood will just run straight in through the veins, into the atria, through the AV valves, and the ventricles will start to fill with blood. And that basically just allows there to be as much blood as possible in the heart before it starts contracting. What happens next is the atria will contract during atrial systole. Now, that was pretty quick there. But when the atria contract, it forces the blood from the atria through the AV valves and into the ventricles. Now, what we can say there is, because the atria have contracted, the pressure in the atria is greater than the pressure in the ventricles, so the blood is forced from the atria into the ventricles. Now, that's quite a short part of the cycle, and it's basically just to ensure that there's as much blood as possible in the ventricles before it gets pumped around the body. So during atrial systole, the atria contract, the AV valves open, the pressure in the atria is greater than the pressure in the ventricles, so blood moves to the ventricles. Following on from that is going to be ventricular systole. Ventricular systole is when the ventricles are going to contract. So here we go. Now, if we pause it there, we can see the ventricles are starting to contract and they force blood upwards and outwards through the semilunar valves and into the arteries. Now, what we can see there is that because the ventricles are contracting, the pressure in the ventricles increases, and the pressure in the ventricles is now greater than the pressure in the atria. As well as that, because the blood is being pushed upwards and outwards through the arteries, because it's being pushed upwards, we can see the AV valves also close. So during ventricular systole, ventricular pressure is greater than atrial pressure, so the AV valves shut. As well as that, ventricular pressure is greater than the pressure in the arteries, so the semilunar valves are open. Now, once it's finished, the heart goes back into diastole. Because the pressure in the ventricles then drops during diastole, the pressure in the arteries is greater, so to stop blood flow from going backwards into the ventricles, the semilunar valves close. But now, because the pressure in the ventricles is quite low, the AV valves can reopen and the heart can fill with blood again. So let's have a look at that. Now, what's absolutely mental about this is that this happens, say your heart rate was about 60 beats per minute. These 3 stages happen once every second, or 60 times every minute. If you were doing exercise and your heart rate goes up to 120 beats per minute, this whole cycle takes place twice every second. Now, it is quite complicated. There's an awful lot going on here. So we'll have a quick blast over it again. So here's what we've got. We'll pause it here. This is diastole. This is where the heart is filling with blood. So blood enters the atria passively. It then flows from the atria through the AV valves and into the ventricles to fill the heart with blood. Following that is atrial systole, which is where the atria contract and they force blood from the atria through the AV valves and into the ventricles. At this point, atrial pressure is greater than ventricular pressure, so the AV valves are open. Following that, ventricular systole takes place, which is where the ventricles contract and force blood upwards and out into the arteries. At this point, ventricular pressure is greater than atrial pressure, so the AV valves close to prevent the backflow of blood. As well as that, ventricular pressure is greater than arterial pressure, so the semilunar valves open. When the ventricles are done contracting, the pressure in the ventricles drop, the semilunar valves shut and prevent the backflow of blood, and we go back to diastole, and the process repeats. So we've got atrial systole, ventricular systole, diastole. Amazing. Now this diagram summarizes what we just talked about there. So during diastole, what we can see is blood flows back in the pulmonary veins. Blood enters the atria and the ventricles from the vena cava and the pulmonary vein. Now we're going to focus mostly on the right hand side here. So the blood returns to the atria in the pulmonary vein. It fills the heart passively, and when it goes into the atria, because the pressure is low in the ventricles, it can just flow straight from the atria into the ventricles. So the atria and the ventricles both fill with blood. The atria and the ventricles are both relaxed at this point. The semilunar valves are closed. Then we go to atrial systole, and this is where the atria start to contract. So the atria contract, forcing blood down through the AV valves and into the ventricles. Following that, ventricular systole takes place, which is when the walls of the ventricle begin to contract and they force blood upwards into the aorta. The ventricles contract, which increases the pressure and forces blood upwards. Because we don't want blood to flow backwards, the increased pressure in the ventricles causes the AV valves to shut. And then blood flows up and out through the arteries. At the end of ventricular systole, the ventricles start to relax, the pressure in the ventricles drop, and the semilunar valves shut, and we go back to diastole. Now, all of those stages and all the pressure changes can be represented in a pretty difficult diagram, but we'll get to that in a little minute. And what we'll take a look at first is this little table. So we've got our three stages: diastole, followed by atrial systole, followed by ventricular systole. So in one cardiac cycle, there's three stages to it. Now during diastole, we'll split this up into the atria and the ventricles. Now the reason why we're only really looking at the atria and ventricles here is because it's the atria and ventricles which contract and force blood to move to different parts of the heart. We know that the valves are involved in it, but the valves only open and shut in relation to the pressure changes. So for example, if the atria contract, it forces blood through the AV valves, but it's not like the AV valves are gates which open and close, and then they control the blood flow. The valves move passively in relation to how the blood is flowing and what walls are contracting. So during diastole, if we look at this, the atrial walls are relaxed. The blood enters the atria from the vena cava and the pulmonary vein. The ventricles are also relaxed and the semilunar valves are closed. And that's because arterial pressure is greater than the ventricular pressure, which prevents the reflux of blood back into the ventricles. As the AV valves are open, blood enters the ventricles from the atria. So, diastole is when both the atria are relaxed and the ventricles are relaxed. As well as that, the AV valves are open and the semilunar valves are closed. So those are the key points there. During diastole, both walls are relaxed, AV valves are open, semilunar valves are closed. Then we go on to atrial systole, which is where the atria contract. That forces more blood into the ventricles, and the AV valves are still open, and that's because the pressure in the atria is still greater than the pressure in the ventricles. So blood continues to enter the atria from the vena cava and the pulmonary vein. The walls of the ventricle remain relaxed, So during atrial systole, the atria contract, the ventricles are relaxed. The ventricular volume continues to increase because they fill with blood, and the semilunar valves are closed. So during diastole, both the atria and ventricles are relaxed, the semilunar valves are closed, but the AV valves are open. The story sort of continues in atrial systole. The only real difference is that in atrial systole, the atria contract, but the AV valves are still open and the semilunar valves are still closed. Then we go into ventricular systole, and the walls of the atria relax, but this time the walls of the ventricle contract. Now this is where the big change comes. The AV valves close because as the ventricles start to contract, the pressure in the ventricles is now much greater than the pressure in the atria. So the AV valves close to prevent the blood flowing backwards, and the chordae tendineae, which were the heartstrings, prevent the AV valves from blowing inside out. As the ventricular pressure reaches its peak, the semilunar valves open, forcing blood into the arteries, and by the end of ventricular systole, the ventricles will be at their smallest volume. So that basically means because they contract, they squeeze really tight to force all the blood upwards and out into the arteries. So that's the process involved in the cardiac cycle. Now, as I say, that can all be represented on a little diagram, which we're going to have a look at now. Now, this is the graph I was talking about. At first glance, it's very, very difficult, and there's an awful lot going on. So we'll break it down step by step here. On the x-axis, we have got time here. And on the y-axis, we've got blood pressure. So it's basically a little graph of time against pressure. Now, as well as that, if we start from the bottom and work upwards, one heartbeat involves atrial systole, ventricular systole, and diastole. So that's one heartbeat. If we go up, we can see the time each part takes. So atrial systole takes approximately 0.1 seconds, according to this graph. Ventricular systole takes 0.1 to 3 seconds, so 0.3 seconds between there and there. And then diastole takes 0.4 seconds. So we've got one heartbeat consisting of 3 stages: atrial systole, ventricular systole, and diastole. One heartbeat takes 0.8 seconds. We then go up a little bit more, and this is where we can see the heart sounds, the. Now, the reason why that happens is because valves are shutting. So you only hear that noise, like let's say a doctor or somebody was listening to your heartbeat, they're actually listening to your valves shutting. So this one here represents your AV valve shutting, and this one represents the semilunar valve shutting, or the aortic valve. If we continue to go up, we can actually see 3 lines here. We can see this blue one, which represents ventricular pressure, an orangey yellow one, which represents atrial pressure, and a red one up at the very top, which represents aortic pressure. So there's an awful lot going on here. These little dashed lines going down just pretty much represent the time. So I was about to say there that it gives you an easier guide of what time this heartbeat is at, but it actually sort of makes it look quite complicated. So we've got one heartbeat split into the 3 main parts: atrial systole, ventricular systole, and diastole. We've got the time over which everything's taking place, and then we've got 3 lines representing the pressure changes in the atria, the ventricles, and the aorta. Now, I should say as well that because this is talking about the aorta, this graph is representative of the pressure changes in the left-hand side of the heart. The right-hand side would look exactly the same. The only difference would be that because the right-hand side of the heart doesn't produce as high a blood pressure, ventricular pressure and arterial pressure would be a lot lower, but everything else would more or less be exactly the same. Now, if we take you through some key points about this graph before we look at it in much detail, Remember, systole basically means contraction and diastole means relaxation. So during this section, the atria are contracting, which you'll remember from like literally about 2 or 3 minutes ago. That means that the walls of the atria are contracting, so the pressure will be slightly higher and they're forcing blood into the ventricles. Ventricular systole will mean that the ventricles are contracting and the pressure in the ventricles will increase. Diastole means that everything's relaxed. Now, at each stage, these are the things you've got to think about. The walls, are they contracted or relaxed? So at A, are the walls of the atria contracted or relaxed? And you just look down here and see atrial systole and think, okay, at that point, the atria are contracted. The next part is comparing the pressure. So where is it greatest? Now this part is where it was really important that you understood the blood flow through the heart. So we know that the blood flows from the veins into the atria, into the ventricles, and then into the arteries. The point where the contraction is taking place is usually where the pressure is greatest. So at this point, if the atria are contracting, the pressure is going to be greatest there. So the blood's going to flow from the area of high pressure to the area of low pressure. So when the atria contract, blood flows from the atria into the ventricles. When the ventricles contract, blood flows from the ventricles into the arteries. Then, which way does blood flow? So that's sort of what we talked about in the last point with pressure. Now it can only flow in one direction, which is going to affect the valves opening or closing. Which brings us on to the next bit. The valves, are they opened or closed? And when we're talking about the valves as well, anywhere we see crossing lines, that means that the valves are either opening or closing. Now, on this graph, there's only 1, 2, 3, 4 places where the valves are opening or closing. Now, I say there is these 2 here, but you'll notice how this is the start of the next heartbeat. So in one heartbeat, there's only 4 places where the lines cross. Now, an easy thing to remember here, we've got 2 sets of valves, the AV and the semilunar. The ones which are between the atria and the ventricles are the AV valves. So B and E relate to the AV valves, and C and D relate to the semilunar valves. Now, I will put up the notes for you in a little file, but if we have a look at this, this is sort of how you can describe what's going on at each place. So remember to use these 4 things. So at A, describe what's happening. The atria contract. Now, because the atria are contracting, if you look closely here, the atrial pressure is the orangey line. So when the atria contract, the pressure in the atria is greater than the pressure in the ventricles. So the pressure in atria is greater than the pressure in the ventricles. So blood flows from the atria to ventricles. And at this point, AV valves are open and the semilunar valves are closed. So what we've done is basically just follow those 4 steps. Which walls are contracted or relaxed? Where's the pressure greatest? Which way does the blood flow? And what's happening in the valves? So at A, the atria contract. Pressure in the atria is greater than the pressure in the ventricles. So the blood flows from the atria to the ventricles and the AV valves are open. Then we come to B. Now, we can see here that this is where the lines cross over. What you'll notice is, in fact, let me zoom out a wee bit. What you'll notice is that the ventricular pressure starts to increase here. Now, if we go down with the dotted line, that's also where ventricular systole takes place. It's also where we get this first heart sound. So what happens at B is the ventricles start to contract, the pressure in the ventricles start to rise, and that has the effect of slamming the AV valve shut. And it is actually slamming it shut, and that's why we get this first sound. So B is where the ventricles start to contract, the pressure in the ventricles rises, and the pressure in the ventricles is now greater than the pressure in the atria, so the AV valve shut, and blood flows into the ventricles. So B, the ventricles start to contract, pressure in ventricles is now greater than the pressure in the atria, so the AV valves shut, and that is the first heart sound, the lub. Because basically when you're describing the heart sounds, it's lub dub, and lub is the first one. This one here is the dub. Lub dub. Now, let's go back to the graph, and we're at C. So the ventricles are continuing to contract, and we come to another set of lines crossing over. Now, if you look closely, at C, the ventricular pressure is now greater than the aortic pressure. So that means that at C, the semilunar valves open. So at C, the ventricles continue to contract. But this time, ventricular pressure is greater than arterial pressure. So the semilunar valves open. Now, the reason why I emphasize that so much is because there's atrial pressure, which is the pressure in the atria, and arterial pressure, which is the pressure in the arteries. So there was atrial pressure and arterial pressure. Now those words sound very similar, but they mean totally different things. Atrial pressure is talking about the pressure in the atrium, and arterial pressure is talking about the pressure in the aorta or the pulmonary artery. It is a really common mix-up, and people write the wrong thing in exams all the time. So anytime you're talking about this, it is really important that you're careful and you take your time and you make sure you say the exact correct one. Now, once we've looked at C, the next part we go on to is D. So that comes at the end of ventricular systole, and we can see D is here. Again, we see another set of lines crossing over. So this represents the semilunar valves closing. And if you look down here, that's where we get the second heart sound. So at the end or near the end of ventricular systole, the ventricles have stopped contracting and they're now starting to relax. The pressure in the ventricles is starting to drop, but the pressure in the aorta remains high. So when these lines cross over, our aortic pressure is greater than the ventricular pressure, so the semilunar valves shut, and that prevents the backflow of blood. So at D, the ventricles are finished contracting and they start to relax. So at this point, arterial or aortic pressure is greater than ventricular pressure. So the semilunar valves close, and that makes the second heart sound, which is the dub. Now we go back up here, and because everybody knows their alphabet, after D comes E, and that E we can see more lines crossing over, and this is the AV valves open. Now just for completeness, this was the AV closed, and this is the AV valves open. So ventricular pressure continues to drop, and during diastole it drops so low that the pressure in the atria, which have been filling with blood, is now greater than the pressure in the ventricles. So the AV valves open and blood starts to flow back into the ventricles. So at E, ventricular pressure continues to drop, and then the atria have been filling with blood. So now the pressure in atria is greater than the pressure in ventricles. So the AV valves open. Now, just that point I was saying about the AV valves, or sorry, the atria filling with blood. Remember, blood flows constantly back into your heart. So at this stage when the atria are contracting, the blood gets forced from the atria into the ventricles. And then the ventricles contract, and the blood gets forced from the ventricles into the arteries. When all that's taking place up here, the atria aren't just sort of sitting there doing nothing. Blood is continually flowing back. So from this point onwards, this increasing line actually shows the atria which are increasing in size and volume because blood is flowing back into them. So at this point, atrial pressure is increasing because the atria are filling with blood. Their pressure continually increases until we get to this point, which is when the AV valves open, the blood flows into the ventricles, and it decreases all that pressure which was building up because they were filling with blood. Now the last section is F. So at F, it's during diastole. We can see that both atrial pressure and ventricular pressure is gradually increasing, and that is caused by the atria and the ventricles filling with blood. Now, as well as that, atrial pressure is slightly higher than ventricular pressure. So at this point, the heart continues to fill with blood, and all chambers are relaxed, and that's because it is during diastole. And AV valves are open, so blood passively enters the heart. Well, we should say enters the atria and flows into the ventricles. All of that has taken place over 0.8 seconds. What the flip? So just two little things to look at here. First one is this little hump around 0.15 seconds. Now, this little spike in atrial pressure is not caused by the atria contracting, because remember, the atria contract between 0 and 0.1 seconds around here. So this little bump here is caused by the ventricles contracting. So because the ventricles are contracting with such force, it creates a little bit of back pressure into the atria and almost gives them a little squeeze and causes the pressure in the atria to increase. But it doesn't cause the valves to open or anything, and that's basically because the ventricles are contracting with so much more force that this little bump here is just caused by a little bit of back pressure from the ventricles contracting. Then we've got the little drop in pressure there, and that's basically just caused by the atria relaxing. So at this point, they're totally relaxed. After that then, as I said, and as I mentioned earlier, atrial pressure is increasing here again, even though they're not contracting, and that's caused by the atria filling with blood. The pressure continually rises until we get to this point, which is where the AV valves open and the pressure begins to drop, because it's the blood which is flowing into the atria just flows passively into the ventricles. Now, just in case anyone was wondering what I mean whenever I say passively filling with blood or passively flowing, it basically means that the blood is just flowing by itself. So it's not moving because of the atria or the ventricles contracting. It just moves because it's a closed circuit and the fluid is moving through it.